So after we did a couple of examples with just the basic long division, we started going to a lot of practice with naming the non-zero digits. So looking at this as 15 tens. And to start there, they always had to start with expanded notation. So they would say that's 105 tens. They would draw it as their 105 tens. 5 tens. And then they'd have to look at the fact that they see a 15 there, and they'd have to think about what is that 15 really? And it's really 15 tens. So there was a lot of practice of this, with them really getting comfortable with representing 150 as some number of tens, or a different number as some number of hundreds, and so on. We'd probably spent about 3 or 4, maybe 4 class periods, not even really doing the long division, and just doing a lot of like exploration with looking at expanded notation and how we can trade in hundreds for tens and thousands for hundreds, and so on, in order to get them more comfortable with the long division algorithm. Once they were comfortable with these pictures especially, I had them go into just kind of getting more comfortable with the language of this division. So we had problems like this one here, 480 divided by 12. So the first thing we would have them do is look at the non-zero digits, and we would underline them. And we'd say, okay, so it's a 48, but it's really 48 tens. I can partly see that because I've got the 1 0 here, so that's the same as 48 times 10. So I have 48 tens here. I'm dividing it into 12 groups. And so again, I was talking about division as not making groups of 12, but making 12 groups. So we're breaking 48 tens into 12 groups. And if I break the 48 into 12 groups, I'll have 4, but they're really tens inside each group. And the value of 4 tens is 40. So they were kind of using this language here to kind of get them back up at the actual answer. And then we would have them check by trying 40 times 12. And again, we talk about the rule of the zeros, that 4 times 12 is 48. And you're talking about 10, so you've got an extra 0 there. So we did a lot of practice with this, where it was really underlining what you have that's a non-zero digit, so 63. But the 63 is really 63,000. I'm dividing the 63,000s into 7 groups, and so I'll get 9 in each group, but it's really 9,000, and the value of 9,000 is 9,000. I'm going to end up checking it by multiplying the 9,000s times 7, and I'll get 63,000. I thought that this was really helpful because this is the kind of multiplication that they'll see in the long division algorithm. So you need to get comfortable with like thinking about what is the true value of that digit that I'm putting there. So what's the true value of the 9, and then multiplying it again by the 7 groups. Because this, when you're doing long division, is what you'd be subtracting from your dividend. Does that make sense?